So again, continuing with general uh, polynomials factoring. Question 24 says factor the polynomial completely, then identify common factors first, then identify special cases. So in this example, again, factoring, what makes it tricky is the coefficient of the x squared. Also, since it's negative, it's not a bad idea to factor the negative out. I prefer the quadratic term to be positive. But notice that all three factors also have a common factor of 5 in them. So what we're going to do is we're going to factor negative 5 out. In doing so, that's going to leave me the x squared. But notice that 30 divided by negative 5, so 30 divided by negative 5 is actually going to be a positive 6 because 6 times negative 5 is 30. So when I factor a negative out, that's going to leave me, since that's a positive 30, we actually need a negative 6. So 30 divided by negative 5 is negative 6 because negative 6 times negative 5 is a positive 30. So that's going to actually make this a minus 6x. And then if I factor a negative out of there, notice how that sign changes to a plus, and 25 will turn into a positive 5. Now, if I run it back through, negative 5 times x squared is negative 5x squared. Negative 5 times negative 6x is 30x. Negative 5 times a positive 5 is a negative 25. So that checks out. Now notice that what's left is x squared minus 6x plus 5. Notice how that fits the category of x squared plus bx plus c. So when the coefficient of x squared is 1, all we have to do is identify the factors of the c that add up to a b. So what we're looking at is the factors, we're looking at the 5, that gives me a negative 6. So only factors I can think of for 5 are a 1 and a 5. But to get a negative 6, something's got to happen here. So they both have to be negative because a negative 1 and a negative 5 does add up to a negative 6. But does a negative 1 times a negative 5 equal a 5? Well, actually, yeah. So the x squared minus 6x plus 5 is actually factorable. It's not prime because there are some factors of the constant, the c, if you will, that do add up to the b, the linear term coefficient. So this tells me I keep the negative 5 out, but this x squared minus 6x plus 5 is going to turn into two binomials. So to get the x squared, it's going to be the x of the x, because x times x is going to give you an x squared. And remember, these last two positions are the factors of the constant. So the negative 1 and the negative 5 do give me the negative 6 in the middle. So that has actually a greatest common factor, but we don't like to keep the quadratic term negative, so we factor the negative out. But remember, when you factor the negative out as well, all the signs inside the parentheses have to change. And then the general trinomial, the factors of a 5 that give me that negative 6, yeah, a negative 1 and a negative 5 do work there. Now, if we want to multiply that all back out, that would give us back to the original polynomial. But they wanted it in factored form and completely factored. So if we stopped here, this would not have been completely factored. We'd have to go one more step to be completely factored.